Okay, the first thing that we're going to start with is the square root of 5. So if we're starting with the square root of 5, what does that mean? Okay, it's the side length of a square. If it's the side length of a square, it's an exact measurement. How big is my square if I have a side that is the square root of 5? 5. Somebody draw me an exact segment is the square root of 5. Okay, so which of those then is the square root of 5?
So I did the triangle, and I knew that 2 squared would be 4, and 1 squared would be 1. I did 4 plus 1 is 5, and that would be 5 if I was lazy enough to.
So this right here, that square right there, is 5. Now let's go back to Pythagoreans. Before the Pythagoreans came along, the Greeks had defined numbers as being any number that could be expressed as a ratio. Now, somebody give me an example of a ratio. 2 over 5. Give me another one. 15 over 100. All of those are ratios. The Pythagoreans started playing around when they came up with this Pythagorean theorem, where this square of 1 and this square of 4 made up this square of 5, so the side length had to be the square root of 5. And they thought that that was okay, except can you express the square root of 5 as a ratio? We're going back to here. We've got the square root of 5, and you say that that is 2.2. The next numbers are 3, 6, 0, 6, 7, 9, 7. Oh, well, how come his says 7 and yours says 8 if they're both calculators? That one's rounding? Yeah. And then what's the next number after that? What's the next number after? It's continuing on. Do we see any kind of a pattern here? Because if I work on figuring it out, I got to use a calculator, but my calculators only go to about 8 digits. Do I know for sure what that next number is going to be? No, I don't know what it's going to be. This was a big problem for the Pythagoreans, because as they started to figure it out, they said, wait a minute, I can't make this into a ratio. And so what they said was, we have just defined that all numbers can be made into a ratio, that I can make it into a fraction of some sort with a number. I proved that there is a number that cannot be made into a ratio. Remember that the Pythagoreans were a very, very secret brotherhood. And so here they had this situation that they had just told the entire world that every number could be made into a ratio of some kind, and then they're looking at this and they say, I can't make that into some kind of a fraction because I don't know what number comes next. It never copies itself, so we've got a problem. And they determined within their brotherhood that they would never, ever tell anyone else. And they made a secret pact that they would die with that secret. But eventually, one of them told. He kind of leaked the word out that there were these numbers that you couldn't make sense of. And so, what do you suppose the Pythagoreans did? There's this story that said that he was fortunate enough to go out onto a boat and return to the mother sea. What they kind of figured is they took him out on a boat and they threw him overboard and said, okay, let your irrational numbers help you now. So what they did was they discovered that there were numbers that were irrational numbers. What we're going to figure out is what's the difference between a rational number and an irrational number. No ratios. So there will be ratios. And again, let's review. What are ratios or fractions? So these can be made, they can be fractions, or we call them ratios. Now, does anybody see a link between this word ratio and rational? So right here, we have ratio right there. What else do we know about rational numbers? Okay, they can end. They may end. May end. What's another word for end? Terminating, okay? So they terminate or they may end. Now really, do any numbers really end? Give me a number that ends. 5 ends? And then it ends? There's nothing that comes after this? Okay, so there's a 0, a 0, a 0, a 0. What comes next?
0.
Yeah, it's a 0. What comes after that 0?
A 1.
A 0. Okay, so here we've got 5.0000. So you can think that it ends, but it doesn't really ever end, because if it ends, what's actually coming after it?
Another 0.
Another 0. It's just going to be 0, 0, 0, 0, 0. Okay? So, and this is, it may end, you can think of it as ending, but really it's just repeating zeros at the end. What else do we know about rational numbers? They don't end. Can you come up with a rational number that doesn't, 3.3 sounds like it ends. 3 repeating what? 3, 3, 3, 3, 3. Okay, so if this is, then what's the rule that goes with that? Because that's a rational number. Yeah. Okay, no pattern. Pi, what does pi equal? 1, 4, what? 1, 5, 7, dot, 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 dot. And I don't really know what's going to come next. So pi is definitely an irrational number. Yes. Okay, it doesn't repeat. Okay. Does not repeat. Okay. Now, with this, ratios or fractions, so I can remember, this is the key here, rational numbers. So you can memorize that rational numbers are ratios and fractions. They may end or be terminating decimals, which is like a 5.0000 or something like that. And it's also a number that repeats, okay? The repeating decimal, okay? Or how could you sum up all of these rules right here? It never repeats. That's all you have to remember, is if a number repeats in any way, then it's rational. If it doesn't repeat, and it goes on and on and on, because a number that ends repeats the zeros, right? So an irrational number is any number that does not repeat. That's really all you need to remember right here. If you can remember this rule, this is everything encompassed right in that one rule right there. An irrational number is a number that doesn't repeat. But remember, terminating decimals repeat. I have a number 5.232323, and it never ends. Rational or irrational?
Rational.
How come?
It repeats.
It repeats what?
2, 3.
It repeats the 2, 3. So there we're good. Okay. What about 6? Rational or irrational?
Rational.
How come?
It repeats 0.
It repeats the 0, so it's going to keep going on and on and on. How about 7.149623 dot dot dot? How come? Irrational, doesn't repeat. What about square root of 2?
Nope.
Nope, what? Irrational, why? It's not doing anything. 1, 4, 2, dot, dot, dot. And we can't see the pattern. It doesn't repeat, so it is irrational. What about square root of 16?
Rational.
It's got a square root sign. So is it rational or irrational?
Rational.
Why is it rational?
4. Because the answer is 4 and the 4 repeats 0.
There you go. Okay? Those were the most commonly missed questions on the walkaway last year. Okay? And it's that simple. Just remember that if it repeats, it's rational. Now what about, let's look at this, 9/16. Rational, irrational. This, the square root of 9/16, 0.75.0000, well, it wouldn't be 0.00 because we'd have two points there. Okay? But does it repeat?
Yes.
So is it rational or irrational? It is rational.